So our next unit has to do with exponents and exponential functions. So our topic obviously is powers, and our goal today is I know the laws of exponents and can apply them to simplified expressions that use powers with the same basis. Okay, again, remember it's the same basis that we need in order to do exponent laws. So we're going to look at, this is 6.1, the exponent rules. Now, some of these exponent rules you've done for quite some time already, so some of this is just review of what you've done. So if I'm multiplying powers with the same bases, and for instance, I have 3 to the power 4 times 3 to the power 6, what we know if we wrote that out in long form, that's 3 4 times multiplied by 3 to the 6. So that's 3 6 times. Now, the reason we have exponent rules is obviously if I had to type that into my calculator 10 times, obviously I'm going to probably make a mistake and I'm going to forget one of them. So the exponent rule, okay, because exponents means the same base multiplied by itself so many times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we know it's 3 to the 10th. So the rule when the bases are the same and I'm multiplying is when you multiply two powers with the same base, you simply have to keep the base, same base, and add the exponents. Okay, so in this case, that would be the same as going 3 to the 4th times 3 to the 6th is the same as 3 to the power of 4 plus 6, which is 3 to the 10th, which is much, much easier than writing out all those 3's. The next rule has to do with dividing powers with the same base. So this is the same kind of thing. I could write out 6 times on the top and divide it by 3 on the denominator 4 times. And then we know that we could cancel. All of these are 1's. And we're left with 3 squared on the top. So the rule here is what we did, had to do with when you divide two powers with the same base, and again, remember, it has to have the same base, you simply have to keep the same base, in this case 3, and subtract the exponents. So if I did 3 to the 6th over 3 to the 4th, really what I'm doing, I'm keeping the same base, which is 3, and I'm doing 6 minus 4, which we know is 2. Okay? Now, powers to powers. What they mean by powers to powers, so what if I have 2 cubed all of that to the 4th? What that means is 2 cubed 4 times. Oops, sorry about that. And we know that when we have bases the same when we're multiplying, we would just add those exponents. So in this case, it would be 3 plus 3 plus 3 plus 3. So we have to the power of 12. Now, obviously, again, that's a lot of work. So the rule is when you have a power of a power, you keep the base the same and multiply the exponents. So in this case, our question that I have written there, to the power of 3 to the 4th, is 2 to the power of 3 times 4, which is 2 to the 12th. So let's look at some examples. Now with these examples, it says use the exponents rules to simplify. I do not want what 2 to the power of 12 is. Okay, it's a large number. I don't want that. I just want to simplify. So let's look at the first one. It says 4 cubed times 4 to the power of 2. First of all, my bases are the same, and I'm multiplying. When I multiply, I add the exponents, which is 5. Now you don't have to show this 2 plus 3 up there. If you do, make sure you keep it up in the exponent area. Okay, now the next one beside it, our base here is -9, so I have to put a bracket around that so that I know the negative is being affected for my base. And again, I'm multiplying, so I add the exponent. 6 plus 3 is 9. So that's simplified. Okay, the next one, I keep the base of 3, power to a power, so 6 times 3 is 18, so it's to the 18. Okay, the next one, again, multiplying. My base is -2, so I have to put a bracket around the -2 because that's the base. Again, I have to add my exponents. 2 plus 4 is 6. Power to a power, so base of 4. 3 times 5 is going to give me 15. The next one, what do I do when I have a fraction to a power of 3? Well, really what I'm doing is I'm bringing that 3 into both the top and the bottom. So it's going to be 3 cubed over 5 cubed. And you're saying, why is that? Well, let's take a closer look at that. That would mean 3 to the 5th times 3 to the 5th times 3 to the 5th. So I could go 3 times 3 times 3 on the top and 5 times 5 times 5 on the bottom. And so when you can see that that's the same as doing 3 cubed over 5 cubed. Okay, now the next one. Notice this time we have a negative here. So it's not a -3 base. My base actually is 3. Okay, 3 to the power of 4 over 3 to the power of 4 is the same as, now remember, we still have a negative in front of there. Equals negative 3 to the power of 4 minus 4, which is 0. And anything to the power of 0 is another exponent law that hopefully you remember is 1. So my final answer is -1. Okay, the next one, same kind of idea here. Notice my base is -9. And I'm dividing. So -9 to the power of 10 take away 5, which is 5. Next one, my base is 11. I'm dividing, so I need to go 9 take away 6, which is 3. Okay, then we get some things that are a little bit more complicated. And it's not that it's any harder. You can do it a couple different ways. I'm going to show you both ways. We can see, first of all, that our bases are the same, both in the numerator and the denominator. So I could simplify. So I'm going to do two different ways. The first way I could do is I could simplify the top first. And so that would be -4 to the 6 plus 2, which is 8, over -4 cubed. Okay, now we know that when we're dividing with the same bases, that what we do is we actually then subtract our exponents. So still a bracket around our base. 8 minus 3 is 5. So I can do it that way. Or another way I could do it is, depending on how complicated it is in the numerator and denominator, I could go -4 is my base. On the top, I add 6 plus 2, and then I must subtract 3. And you can do it this way as well, and you get the exact same answer as before. Okay, so either way is acceptable. Totally up to you which way you choose it. Okay, so this one here again, so I have 3 to the power of 8 on the top, 3 cubed on the bottom, which is 3 to the 5th, because I need to subtract. Okay, and I'm not going to do that one the other way, but you could do it quite easily that way. So let's look at the second types of examples. Okay, example 2 says, use the exponent rules to simplify the following algebraic expressions. Now, the first thing that I notice when I look at this, I'm just going to bring up the screen for a second, is it looks a lot worse than what it is. Okay, so the first thing I would do is I would do any power to the powers first. Okay, so I'm kind of in my head, I'm going to do power to power because those have brackets. So if I look at my first one, that's here. This is to the power of 0. Anything to the power of 0 other than 0 equals 1. So the first thing I'm going to do is I'm going to replace that 2mn. I'm just going to make it disappear because it equals 1. So I have 3m to the 4th n to the 6th times 2m squared n. Now, if I look at just the number portion, I can see I have a 3 and a 2. The 3 and 2 are not like bases, so the only thing I could do with those is multiply those. So 3 times 2 is 6. So I could put 6. The next thing I look at, because everything here is being multiplied, I have a base of m. The first one's to the power of 4, the second one to the power of 2. So if I add those exponents, because I'm multiplying, I end up with m to the power of 6. Finally, if I look at my n's have the same base. The thing is, my second one is actually to the power of 1. We usually don't show that 1 there. It's just assumed that we know it's there. So 6 plus 1 is 7. Okay, so that question is finished. Okay, so the next one I'm dividing. So the first thing I would look at if it was me is I'm going to use my magic pen, so I'm going to look at the number part, okay, the coefficient part. So I have negative 28 over 7. Okay, neither one of those have the same base, and I can't make them have the same base. The only thing I can do with negative 28 divided by 7 is to actually calculate it, which is negative 4. So that's the first thing I could do with that. So I'm just going to use different colors so you can see. So negative 28 and 7, so we're looking at 4. Okay. And the next thing I'm going to do is I'm going to look at my A's. I have 6 A's on the top divided by 11 A's on the bottom. So it means that I have a to the negative 5. Now, it means also that the bigger number, which in this case is 11, is on the bottom, so it has to stay on the bottom. So I'm going to leave it as a to the positive 5. I think that's what I'm going to do. Yes. And now I look at my B's. I have negative 3 on the top, and I have a negative 5 on the bottom. Negative 3 take away negative 5 is the same as 3 plus 5, which would be b squared. And I'll look at this question in a little more detail in a second. On the top I have c to the 5, and the bottom I have c to the 5. 5 take away 5 is 0. Which is 1. So this answer is finished now. Now you're saying, okay, I missed that negative part stuff that you did. I'm assuming everyone got the 4 part. Let's look at that A again. So if I do 6 take away 11, and my B is negative 3 take away a negative 5. You can see what we have here is 4, sorry, actually it should be negative 4, a to the negative 5, b to b squared. Now normally we don't like negative exponents, so that's why we flip it, and we can look closer at that later on. So that's how come that negative locates down here, and because then it becomes positive 5. Okay, so I'm going to stop the video, and we're going to do the last example, like number 2, and then we have a little bit with number 3.